Hello everyone. Today we are going to go through our LeetCode daily, which is minimum number of operations to make an array continuous. So basically what is happening is that you receive as input an array of numbers and you're supposed to make that array continuous, and the continuity of an array here is defined by no element being repeated in the array, and the difference in between the maximum and the minimum of the array is equal to the num.length minus 1. What does that mean? Basically, in literal English, it will be to have element from the first to the last appear, all elements from the first to the last appearing in the array. Let's say we have an array like this moving. We have 4 2 4 2 5 and 3. We can all agree that in this array the minimum is 2 and the maximum is 5, and then all elements from 2 to 5 are actually appearing in the array, so the result is 0. That means it is already continuous because we have all integer from the minimum to the maximum appearing in the array. So that is the first step, understanding that you need to transform an array into such a way that the result array will be an array where we have all elements appearing from the minimum to the maximum. Now that you understood what you are supposed to do here, the tricky part is how do we achieve that? How do we transform our input into an array respecting the condition we just mentioned? That is what we are going to go through in this problem. Before we start, if you are new here, here is Agro Architect. Here we are going through LeetCode daily accurate solution. So if you are interested into leverage your level in data structure algorithm, don't hesitate to subscribe. Do not miss our daily video regarding this topic. So let us dive into our problem. We have just stated the situation of the problem. Now we have one example. We had one example. Let us have another example to understand better. Let's say you have this array. The array consists of, let me take this array. Let's say you have this array. The array consists of 2, 4, 9, 3, 6, and 5. In order to make this array being continuous, I can keep the 2, I can keep the 4, I can keep the 3, I can keep the 6 and the 5. Now, I can change this into 1, this 9 into 1. If I change this into 1, I will have 1, 2, 3, 4, 5, 6, which is a continuous array. Or I can still change this into 7. In that case, I will have 2, 3, 4, 5, 6, and 7. So those are two valid solutions. So in this scenario, you don't really care about what element has been changed. You mostly care about how many elements has been changed to make the array being continuous. In this scenario, so those two elements are actually valid solution. Now that you have this, what will be your thought process of solving this? So my solution will be as follow. The first idea I will use is I will take any element of the array. So I will look from all of the elements of the array from left to right, and for each of the element I will consider that element to be my minimum. And once I have that element to be my minimum, I will actually look through the rest of the element and see how many elements I can keep to have my array being continuous, and the rest and the size of the array that I have with the element that I can keep, I will just reduce it from the total length I need to have. Okay, let us take this one for instance. We have an array starting with 2, so I'm going to move from 2 till 8, because moving from 2 to 8 is actually the size of this array. The idea will be, okay, moving from 2 to 8, 2 is already part, so I have one element which is 2. I'll move here, 4 is part, so I have 4 is in this range. I'll move here, 9 is not in the range, so I will not take 9. 3 is in the range, I will take 3. And then since the array needs to be continuous, you do agree with me that I can't take 3 2 times, right? So this element should actually be a set. So I can create a set in which I will just, so by inserting 3 the second time, it will actually kind of erase it, and the size of the array will still remain 2. We still remain 3. instead of 4. So I will use the state, and then I will put all the element which is in the range of 2 to 8. And then is 6 in the range here? Yes, I will put 6. Is 5 in the range here? Yes, I will put 5. By doing so, at the end of this, I will compute the size of this. The size of this will actually tell me the number of elements that need to be complete in order for this to be successful or to be continuous. So in this scenario specifically, the size will be, we have 2, 4, which is 1, 2, 3, 4, 5. So we have 5 elements. So we have a size of 5 elements. And then here we are expecting to have an array of size 1, 2, 3, 4, 5, 6, 7 elements. So basically, in this specific scenario, you need to add 2 more elements to have the array being continuous. And what are those 2 elements? Let us have, we are moving from 2 to 8. So those 2 elements are actually element 8 and element 7. So if I add element 8 and 7, I'll be able to have this array being continued. So basically, this can be changed into 8 and this can be changed into 7, and this array will be continuous. So that is one way of seeing the thing. So this can change into 7 and this can be changed into 8. So if I am to code this, what will it look like? So to code this, I'll have something like this. So like I said, I'll create a for loop that will loop through all of the elements. For each of the elements, I will initiate an empty set, and then that empty set will be used to loop through all of my elements. Since I'm considering the element at position E to be the minimum, so I will take all the elements which are actually greater than E and less than the maximum, which is num of E plus n. So by doing so, at the end, the size of this will actually reflect the number of elements that can be used to have the set, and the n minus this will actually represent the number of elements I need to add. And then I will actually keep this solution as a sub-ans, and then I will say, okay, if the sub-ans is actually less than the previous ans we are having, so we just take this one. So at the end of this will actually help us to solve the problem. But there's one issue with this. We are going to fall into time limit. You're going to see. So if you submit this, you are going to find yourself into time limit. Now, what can we change into our approach to make this successful? So basically, another way of seeing the thing is, we can still keep the idea of that we want to use the brute force approach, but we can optimize it a little bit to make it like more optimal. Optimize to make it more optimal. So we can optimize it a little bit to make it go faster, right? So the idea of optimizing it will be like, instead of taking element and looping through all of the element, you can actually, let me draw this line and take this for instance. You can actually sort your array first. So let us say if I have this, you can sort your unique array. So you have 2 here, you will have 3, you will have 4, sorry, this is 3, you will have 3, you will have 4, you will have 5, you will have 6, and then you will have 9. So the idea here will be as follows. The idea will be as follows. I will sort my array first, and then now what I will do is that I will start from the first element here. I will consider this to be the minimum of my array, and then I will loop from the minimum till I'm seeing an element which is actually out of range. This is actually not a good example. Let me complete it more so we can see. I can put 10 here, I can put 12 here, I can put 13 here. Okay, so let's say you have this array for instance, and then you want to go from 2 till we have 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. So you are going to move from 2 till 10. Yes, from 2 till 10. So what you will do is that all of the elements, you are going to have the first index, which is I here, which is going to be used for the minimum at that iteration, and you are going to have another iterator element, which is actually G, which is going to loop from the first one till the element where we cannot longer put into our set of the current element. Now what is interesting is that after the second iteration, you don't need to, you are going to keep the G, and then you are going to just move the I one step forward. So if you move the I now here, if you move the I here, you are 100% sure that all of the elements from this I to this G are actually part of the set, because you were with an element which is actually lower than this one, and now you are in a guy which is a little bit greater. So all of these elements will actually fit here. What you will need to do is just to update this G and see how far you can go from this position. So by doing this, you are still into big of n square, but you are kind of optimizing the algorithm because you are not looping through all of the elements many times. So this is the optimization we are going to use. And what would the code look like of such optimization? It will look like this. I will have I will create the first sort array of, I will create the sort array of minimum. I will create the sort of unique element. So the sort of unique element will be as follow. You create a set because you want them to be unique, and then since it is a set, it's going to sort the array automatically. And then after sorting all the array that I have in my set, I will now, after just adding all of the element of my array in my set, it will automatically sort the element and remove duplicate. And after those elements being removed, I will create a vector, and I'll put all of the element of my set into my unique nums. So at this position, I'm here. I have my array of sorted element. So now I will have the visited being here outside here, because I want to, I want him, I don't want to reset this element. I want to keep the position where the element is. And then whenever I'm changing the G, I'm just going to push this one, because I'm 100% sure that all of the previous elements of the G can actually be used. So this loop is actually almost the same as we were having previously. We check if the position of the visited is actually less than the size of the num, because you don't want the G to exceed the size of the array here. And then you check if the element at the position visited is actually less than unique of the minimum plus n. That means you check that the element where we are here can fit into the element of the range from the minimum to the maximum, and then the maximum is actually me plus n. So by doing so, if this condition is not respected anymore, that means G has reached the position where we can't add any more element to our set. And then by doing so, you just compute the difference in between the G and the minimum. From this position, this is actually the sub answer. I mean, like the subset of element that can be used to make the array continue considering this me to be the minimum. And then by doing so, you just check if this answer is actually less than your previous answer. If it is the case, you keep it, and at the end you will have the solution. Let us run and see what it gives. So now this solution is actually passing this, and then it is also passing all test cases. It is true that the solution is not the best in terms of performance, but it is actually solving the problem. So this was my approach of solving this. I hope you do enjoy it. Feel free to leave me any input that can help us to kind of make this algorithm better. I'll be really happy to interact with you regarding this. See you on the next video. Ciao.